Hey guys, welcome back to another video. In today's video we'll be making a spectrogram, not just any other spectrogram but a circular spectrogram. And this project is really personal to me because this is what got me deeper into programming as a whole. I started programming in Godot, the game engine, and then kind of got into making generative art and stuff like that, and ultimately ended up in P5JS. And then I saw someone make a circular spectrogram, or they called it Irisgram, on Vimeo, and I was really excited about it, and I was like, you know what, let me give it a shot and let me try making a circular spectrogram and see how that goes. And I failed because there were no resources online on how to create a circular spectrogram, or spectrogram at that. So last week I kind of took it back and ultimately I completed the project. So yeah, I'm happy to share this video with you guys. I got the knowledge for free from Reddit, so why not, pass the knowledge forward to millions of people online. Hopefully millions, fingers crossed. Yeah, let's get right into it. So let's start with what a spectrogram really is. So a spectrogram is nothing but a neat way to visualize audio information. So we get a spectrum of values, which is going to be our frequency, and then we're going to use that weight, which is going to be the magnitude, the amplitude, and use that to tweak some value within our draw function within P5JS to kind of represent the audio information. Let's get into the basics of how we're going to do it. So for this video, as I said, we'll be making a circular spectrogram. You can also make a rectangular spectrogram, which will be something like this. This line you see here is going to be, at any given time, this is going to be our entire spectrum. So this spectrum is going to go from, let's say for our human range, it's going to be 20 Hertz here, and the range is going to go up to 20,000 Hertz. So when t is equal to 1, we'll draw another line again with a variable that is obviously another spectrum of the audio file. If this sounds a little complicated, I think I do not know how to explain it well enough, so bear with me. We'll get into programming and kind of you'll figure things on your own. I'm just kind of laying out the basics to kind of have a basic understanding of what we're about to do. So the circular spectrogram is the same thing, but we're going to draw something from the center. So this is going to be our center, and at T1 we have drawn a spectrum of values from, in our case it's going to be from highest here to lowest here. So it's going to be 20 here, 20 Hertz, and 20,000 Hertz here. And obviously you can get it from a reversed value simply by reversing the spectrum array, and you'll get a spiky dandelion shape, which, if you like, you can go for it. So now as time increases, instead of kind of moving along the x-axis, we have to increase an angle. So when t is equal to 1, we have to draw a spectrum here. Now this angle is what we are going to define and make some connection with the song duration, because when you think about it, the song duration, we have to cut the song duration into equal parts, and this equal part is going to be that angle. So we have to change the angle in equal parts to cover the entire circle. So this is going to be our angle. So our angle is equal to 360, obviously because we are doing a full 360 rotation, divided by the song duration, because we want to get equal parts of that song duration, based on the song duration, and at last we'll also multiply it by frame rate. So this is going to be our, I don't think you can see it very well, but this is going to be our angle. So now there are two ways of drawing the circular spectrogram itself. So one way is to keep the starting frequency at time is equal to 0, and as time progresses in this song or the audio file, the new frequencies are going to go away from the starting point, like in this direction. So here are the new frequencies. So as the entire thing progresses, the new frequencies ultimately will end up here, like this. So that's one way to represent the circular spectrogram, but another cool way is to keep the new frequencies at the starting point. So here is going to be the new frequencies, and as time progresses, you keep the old frequencies away from the starting point. Obviously the second one is a little bit more difficult, involving a couple of push and pop methods and layers, which is something I really struggled with in the past 3-4 days to kind of figure out how do we do local rotation and global rotations, but I'll teach you guys how to do that. Yeah, so this is the basic concept. Hopefully you understood. If you didn't, don't worry, we'll get into the programming and I'll try to explain it there also. So with that being said, let's jump into P5JS. So the first thing I want to talk about is the two buttons I've added here, play and save. I've done it in the index.html file. You can just go to the main and add a button ID audio on click. The reason I've added a tag or the ID for the first button and not the second button is that because the first button will be called inside the sketch functions, but the second button, the save button, is actually a built-in method within P5JS. So you can just say save canvas, give the name of the file you want to save and the format. For me it's PNG. So now if I hit save, I'm going to download as you can see, I've downloaded a PNG, a screenshot of the canvas basically. With that said, let's get into our sketch. So within the sketch, we'll start off by writing a preload function. The reason we need a preload function is to set up an audio file before we call anything else, so it's completely loaded. So the first thing we have written is a song variable that's going to hold this song or the audio file that we're going to load. The next thing what we're going to do is define a playing variable. So we're going to say playing, and we're going to set it to false, because think about it, when you load or play the sketch for the first time, you're not playing the song. Only when you hit the play button here is when your playing is going to be true. So that is going to be false. The next thing we want to define is a onEnded function. So what am I supposed to do when the song is not playing, right, or the song is completed? So we're going to say song dot onEnded, and within this argument we're going to give an anonymous function, and the first thing we're going to say is obviously set playing to false. So think about it, when the song is playing, you click the pause button, the song is not playing, or the song is ended, the song is not playing. False, and we do a semicolon and then change the text of the play button. So when the song has stopped playing, the play button is going to say play. When the song is playing, the play button is going to say pause. So now we have to define the pause text. Audio, so this is why we needed an ID for the button, so we can manipulate the interior text. So inner text equals play. And the last thing we're going to do is set the angle variable that we'll define later on, but for now we'll just set the angle to 0. So when the song is complete, we will set the angle to 0. Now this obviously poses a big flaw in the system, which I will get on later on. But the thing is, when you pause the audio, where you left off in the spectrogram is going to be way different from the actual song, right? So what I mean by that is when the spectrogram is playing and then you pause it and then you play again, the spectrogram is going to go from the start because we define the angle as 0. So now if you have any workaround for this, please do let me know in the comment section below. So the next thing we're going to do is define the frame rate. We're going to say FR is equal to 60 FPS. The next thing we are going to do is define the actual toggle function that we have written in the button index. So we're going to come down. So we're going to say if the audio is not playing or if the variable is false, then play the song. Also for convenience, we are also going to console log this thing. And after that, we're going to change the inner text of the button to pause. We're going to copy this line from here, Control C, Control V, and change that into pause. Now what do we do if the song is already playing? We're going to write an else statement. So I'm going to copy the whole thing here and I'm going to paste it. And when it's playing, when we click the button, it's obviously going to pause, and we're going to console log it as paused, and we're going to say the inner text of the button into play. So I've quickly uploaded an audio file here. It's a song from audio library, so it's copyright free. And to load the song, we simply have to come to the song variable in our preload function, and within double quotations we just have to write the song name with the format .mp3. So now when we hit play, our song is playing, and also we have a console log as playing. So when we hit the play button again, as you can see, nothing happens because we forgot something. We have to come down to our toggle audio function once again, and we're gonna say playing is equal to not playing. So when we do that, so we have playing and the audio is playing, and when we press the pause button, it stopped and we have a console log confirmation saying the music has been paused. So now we have the basic mechanism to play the audio out of the way. Let's move on to actually making the spectrogram. Let's get into it. So the first thing we're going to do is, as I mentioned earlier, there are two ways to make the circular spectrogram. One way is keeping the old frequency at the starting line or the starting radius, and then as new frequencies come out, they go farther away from the starting radius. Or you can have the new frequencies at the starting radius and then make the old frequency go away. So firstly, we'll do the old frequency staying at the starting point, and then we'll go on to the more complex one. So let's get started. So we're going to leave create canvas as it is, but we'll increase the resolution by 500 by 500 so you guys can see better what I'm doing. Now here comes the important part. We have to define a variable that is going to hold our fast Fourier transform or FFT object. Now make sure you do have P5.sound library added to your index. Otherwise you won't be able to even access the load sound and also the FFT or the amplitude objects. So I'm going to define it really quickly here. So now once we have that, we can go on to define our angle. So A equals, as I mentioned earlier in the paint sketch, you can go on to say 360, the amount you want it divided by. For us it's the whole circle. For you, maybe you want to make a half a slice or maybe a pizza slice, so you can just really play on with the angle here. And then we're going to divide it by the song dot duration, and this song dot duration is also a method, so make sure you put this brackets here into our frame rate. We'll also define B, angle 2, which is going to be A, and at last we'll give the frame rate as FR, so our canvas runs at 60 fps. So we have the function setup done. Let's move on to our draw function. So with our background done, the next thing we want to do is get the variables going. So as I said before, we're going to use a spectrum of values, and the spectrum is going to go from 20,000 or whatever the value is being returned to us. The line is going to represent that spectrum, so we need a spectrum first. Luckily for us, we can just say spectrum. So FFT analyze is going to return that spectrum array. We'll also define a spectrum B, which is going to be spectrum A dot reverse. Last but not least, we also have to cut out certain unwanted frequencies. You'll get what I mean when we actually have the line set up, but for now I'm just going to leave these two lines here, but after we make the spectrogram you will understand why we'll need to cut out certain frequencies. So with that being said, let's move on to our actual push and pop methods. For beginners, push and pop might sound a little bit intimidating because there's obviously, when you're starting JavaScript, there's also push and pop with arrays. You can do array.push, array.pop. So that might be a little bit confusing. This is kind of a confusing term to use, but what it essentially means, the code inside this push and pop is going to be separate from the rest of the code inside your sketch. So for example, I'm going to demonstrate really quickly. As you can see, inside a push and pop, the center is 250 by 250, but outside our push and pop, our center is at 0 and 0. So hopefully that makes sense. Essentially, whatever you do within your push and pop only stays within your push and pop. So this is going to be our local, and this entire thing is going to be our global. So with that explanation out of the way, let's get into our spectrogram. So obviously we're going to keep the transform or translate, and then we're going to rotate it by radians and give it a value of our angle. And we'll come outside our pop and increase or change our angle by some amount, that is plus equals b. And then we simply have to run a for loop. So within the for loop, here is where we're going to draw the line. So we're going to say stroke weight is going to be some amount 0.08. In my case, this value has worked very well for me. So into a spectrum I. So this is going to be our defining factor of the spectrum itself. The next thing we're going to do is set the stroke color itself. For now, I'm going to stick with a grayscale value. The only thing we'll be changing is the alpha or the opacity. Next we'll draw the line at 0 I 0 I. Now let's see if this works. So the problem here is our line, the length of a line is way too big. So we can just say I divided by 4 and I divided by 4. So we can see a line here, so we'll decrease the amount by a little bit more. So now we have some kind of visuals going on, but it's not exactly what we want. For starters, our line is not being saved over time. That is not the problem. The problem is, as you can see here, a background is being called at each loop. So what happens is we draw background and then we draw the line, but then we come out again to call the draw loop again. The background is drawn over the line we have already saved. So this can be fixed easily by going over here and putting the background in the setup function. Now this is going to be a little different based on the second type of spectrogram we'll be making. So that's where I got confused and kind of put it in the draw function. So yeah, no big deal, we can just change that. And now once we have changed that, I'll also change the stroke weight to 0.008. And let's see if it works. So now we can see we have a spectrogram going, and so the next thing I want to teach you guys is colors. Okay, we can add colors based on the spectrum values. So some of you might be watching and you might have already figured it out. That simply we have to somehow connect the spectrum value to the stroke color values. So I can simply say stroke spectrum B 255 or any value for that matter plus spectrum B. So this operator can be any of your choice. It could be multiplication, division. It just have to be connected with the spectrum. So when the spectrum value changes, the color value also changes. So let's check it out. So now as you can see, we're kind of getting a gradient here. For loud frequencies, we are kind of getting a white color, and for lighter frequencies, we are getting lighter amplitude, sorry, you're getting a bluish color. So as you can see, the more loud frequencies in this song is going to be the low end, is having more whitish colors, more bright colors, and the high frequencies which have low amplitudes is having a bluish kind of color. So you can also experiment with different colors and the operators as I mentioned. You will get different results and make it more attractive as a visual presentation. Immediately you can also find another problem, which is the length of our spectrogram. We are starting not from the center but rather from here. As you can see, this is going to be our curve, and the whole spectrogram is going to move around this circle. This whole big circle, imaginary circle, is going to be the center. Now here's where we want to cut out unwanted frequencies. This is depending on different songs. Maybe for more concentration at the high frequency side of spectrum, you might want to remove the lower frequencies, and for songs that have concentration at the lower frequencies like this one here, you might want to cut out the unwanted higher frequencies. So we're going to do that by simply coming to our spectrum B, splice it, and we're going to remove from the index 0. This is not the hertz, this is from the index 0 to 60. If you fine tune this, you will get to the center at one point. So now you can't see as much of a difference, so I'm going to increase this by a big amount just to show you the difference, right? This part of the song doesn't have too much high frequencies. But now you can see the center has become a little bit closer. So we can see the circle has shrunk quite a bit. I'm also going to make it a little bit more high, just so you guys can see. Now if the length changes because you're cutting out the values from the spectrum or the array, you can simply change the length here. Now as you can see, it's more closer to the center. But for now, for this video, I'm just gonna keep it back at 60, and we'll work on further from that. So now as you saw the spectrogram, the new values were going away from the center and the old values were staying at the center. So now we're gonna make a spectrogram with the new values at the center and the starting point I should say, and the old values going a full circle around and then coming to the starting point. So now this is going to get a little bit more tricky. We are going to use something called layers, similar kind of thing you use in Photoshop. You put layer on top of each other and then draw in that layer, and that layer's local rotation or transform is not going to be equal to the rest of the layers in the canvas. So to do this, we have to start with creating a new canvas. So let's say layer is equal to create, not canvas but graphics, and we'll also give the same width and height as our canvas. So this layer is going to be our second canvas. It's going to be a transparent layer. Now since we won't be using the create canvas as canvas to draw the lines, we can simply put the background back into our draw function, but I just want to see what happens when we have it in our setup function. Now we can come to our layer dot clear. So what this does is essentially it's transparency for the background, and we'll come to our draw function and we'll say layer dot no fill. And this is very important. I kind of forgot it when I was kind of starting with create graphics and stuff, is I forgot to put the layer dot and call the property of the layer. Instead I just put layer no fill, and this is going to be the property of the main canvas. We don't want to access that. We want to change the property of the layer we are working on. I'll put that here. The variables don't have to change, but this is going to change quite a bit, this line. Now we're gonna push this inside our global canvas, translate it here and rotate it. That is not going to change, but we have to come down, and then again we have to push a local canvas, right? We just created a local layer, and we have to do the same thing. We have to do this same thing, but instead for our local layer. So we'll just say layer.push and layer.pop. So now within this layer.pop and push, we again have to translate it because we need a center and a rotation center. So we'll copy this, and again don't forget to call the property of the layer, not the main canvas. And for the rotate, we have to be counter rotation, so we see the effect of the starting point being new frequencies and the old frequencies being moving away from the starting line. So this radiance should be actually -a, and then we can write the for loop. We'll copy the for loop here and pop it here, and now obviously we have to call the layer once more because we are not drawing on the main canvas but rather on the second canvas named layer. So we'll do that here, and once that's done, I think that's pretty much it. Let's give it a shot. Okay, so I've made a silly mistake. The reason we're not seeing anything here is because we're not displaying the canvas we just created. As of now, we can only see one canvas, and that is the default canvas, the create canvas here. And we cannot see whatever we have done on this canvas because we haven't displayed that canvas. To do that, we just have to come down here and say image, layer, and make sure this is minus width by 2, the X and Y position. So now hopefully it should work. Okay, so now as you guys can see, the starting frequency is here and the new frequencies are here. So this is what I wanted to do. So now we have got a bug here, and honestly I don't know how to fix this. I think when you press play, the angle sets again back to 0. So as I mentioned at the starting of the video, you might get a bug because of the angle resetting to 0. And that's what's happening here. So we can see it's -a here, and we're not saving the angle at pause. So when we pause, the song is this function gets triggered, the on-ended function, and the angle kind of gets reset to 0. So when we play again, it's gonna start from 0, as you can see here. So if you guys have any solution for that, make sure you leave it in the comment section below. So for now, the only way to kind of save the spectrogram is let the song play through completely, and once it is complete, you hit the save button and you'll get a download here. So the last thing I want to do is actually add a line spectrogram just to make the thing look cooler. The way we're going to do that is by begin shape and end shape, and I'm going to kind of come back here and let's do another push and pop. Now this is going to be on the main canvas, so you don't have to go through all of this confusion. We don't have to deal with that. Also, we're not rotating the thing, so and we're going to say no fill because it's a line, and we're going to give the stroke to, I'm going to stick with red for now because it's contrasting with the blue. And we come here, we'll say begin shape, and end shape, and we'll also write a for loop, and within this for loop we'll define an amplitude, and that's simply going to be the amplitude of the spectrum value or each frequency, right? Spectrum.I, and we'll say var x is equal to, we're going to map that spectrum value amp, and this is going to be dependent on the FFT here, and you can put the FFT 0 smoothing, and you can have about 256 bands or 1024 depending on that. So I can come here and say between 0 and 255 or 256, and then I'm going to map that to between -1 and 1. And the reason I'm doing -1 and 1 is because since we are on the x-axis, and I forgot to translate it. And so the reason why we're doing -1 and 1 is because we want the line to be here, and then the actual waves or the spectrum or the frequency has to go in the x-axis, something like this, not like this but like this. And we'll keep the variable y equals, we'll map I this time, and we'll go from 0 to spectrum.length. The length of this line is going to be dependent on A, your splice, how much you're splicing out, because then your center might be here or here or here. In our case it's somewhere over here, which I can't see right now because the audio's frequency has an empty range over here, so that's kind of difficult to know. I'm going to go arbitrary, and 2, the factor that dependent on is the length. So since we divided by 5, our length is only till here. This is going to be our radius, so we'll have to kind of do a guesswork here. Again, if you have a parametric solution, I'll be glad to hear it in the comments below. So we'll say, I'm gonna guess here about 40 pixels, and since we have 200, so I'm gonna say 300. I'll draw a vertex with x and y. So now if we see, we will have a line. Okay, so 300 is way too high. Okay, that's confusing. Okay, so that I think is alright. So when we play, so what I did here was change the background from our setup function to our draw function, and then come down to the stroke weight, and I also increase the stroke weight a little bit. So now if we put 2 and then play, we should see the proper results. So now we can see the actual result. We can also see the line visualizer. So that's it for the circular spectrogram. If you guys enjoyed the video, make sure to leave a like and do subscribe for future tutorials and programming stuff. I know the code isn't clean and optimized as much as I would like to. There are parts that are time consuming and unnecessary, like the variable length of line visualizer and the radius of the circular spectrogram. I know we can make a single variable and kind of connect them both, but we need to find the connection. I will leave that up to you guys, the sketch in the description, so you guys can go and make optimizations and make a spectrogram of your own. With that being said, I will see you in the next video. Bye bye.